So hi everyone, I'm David. I'm a site reliability engineer, and my talk is finding useless and resource-hungry Prometheus metrics. So I've decided afterwards that useless is a negative tone, so that's why the title is like that. Doesn't work. Okay. So to give a bit of context, so I have had this talk idea by I was recently given the task to fix a Prometheus setup. It was unstable. It has a lot of pod crashes, things like that, because it was running under Prometheus, under Kubernetes. It had many cardinality issues, and it was also using a lot of resources. So we had to do something about that. So this talk is divided into 3 parts. The first, we're going to see how we can use Mimir tool to analyze our Prometheus metrics. Then we're going to see how we can find and analyze high-cardinality metrics using Prometheus and Grafana. And finally, I will share a potential quick win to reduce even further the Prometheus resource usage. So let's start with analyzing our metrics with Mimir tool. So when I first had this task, I was asking myself, well, what's coming into the Prometheus instances? So I've had a look using this PromQL query to see all the metrics, the list of metrics that was here, but there was something missing. Like I didn't know what we were actually using and what we didn't. So I did a bit of research, and I've come to Mimir tool, which is a CLI tool that can be used to do various operations around Prometheus. Like the name implies, it's, of course, part of the Grafana Mimir project. So you have the documentation link if you want to learn more about the tool. But we're going to mainly focus on one part of the tool, which is the analyze part. So using Mimir tool analyze, you can analyze Grafana, rulers or Prometheus rules, and also Prometheus instances. So when you do that, so you will need to give it the address of your Prometheus instance and an API token, so a service account token now. And it will, if you do that, it will output basically a file which is named metrics.grafana.json, and it will include all the metrics sorted by, all the metrics that is actually used in your dashboards and panel and stuff like that. You can do the same thing for the Prometheus rules. So basically what it does, it would go through all your alerting rules and recording rules and do the same thing, like have a list of what's in there. And finally, when you test that against your Prometheus instance, it will grab the 2 previous files and compare them with what's actually inside Prometheus, and it will output a file named prometheusmetric.json, and it will actually have it separate which is actually used and which isn't. So metrics will, so the file look like that. On the left, I've shrinked it a little bit so you can fit in a slide. But basically on the right, you see an example of an entry. So basically here we have etcd request duration seconds bucket, where we can see the cardinality of the metrics and what job it's, and we can have that by job also. So why it's important to know that? Because when you know what you are using and what you are not, you can have 2 things. It can be an opportunity to monitor things that you were missing before. So you can have maybe new panels, new dashboards, new alerts. So there's going to be new stuff that you can have a look at. And it could also be an opportunity to clean some things up that you don't particularly need. So you can either remove it at the source, so configure your application on your exporter to don't send it to Prometheus in the first place. Or you can, if you can do that, you can use relabeling to do it. So it's always best to do it as close as possible to the source, because you will not get like network penalty, all of that. So for example, the Prometheus node exporter has a notion of collector. So you can enable or disable especially connectors. So for example, in this example, we disable the ARP and SOC stat. But if you don't want to disable everything, you can like either there is include and exclude path that you can use on this exporter. Unfortunately, not all exporters will support that. So when it's not possible, you can still like decide to drop labels using relabeling rules. So for example, here we are just dropping the metric that we took in the exam before. So if you want to learn more about relabeling rules, you can have a look at the docs. And if you want more examples of the different configuration earlier, you can have a look in Kube Prometheus stack. The end chart has a lot of examples of things you can do. So there's still things to consider. So the metrics usage, so as we've just seen before, we compared our Prometheus rules and our Grafana dashboards against our Prometheus metrics, but maybe you are using your metrics elsewhere. So for example, if you have HPAs, maybe you are using a particular metric exclusively here that is not present anywhere else. So keep in mind that you will maybe need to import metrics you are using elsewhere if you want to have the list correct. And finally, the goal of this is not to drop everything that you are not using, especially since some metrics can be really useful during debug sessions and incidents. So choose wisely, and of course, focus on the ones that will with the highest cardinality. So now we're going to see how we can find high cardinality metrics with Prometheus and Grafana. So as you may have seen on the Prometheus UI, you have a TSDB status page where you will find a lot of resource, useful information about the TSDB, one of which is the top 10 series count by metric names, which is basically the metrics cardinality. And if you want to learn, like if you want to have more than the top 10, you can use PromQL to do so. And you can do, of course, for all the others. Just replace the number you'd like from this PromQL array, and you will have the list. So once you have the list of your biggest metrics, what you want to do is understand why they are big. And you have several ways to do it, but I found that there is a dashboard on the Grafana community, the dashboards that is really well made. And basically what it does, it allows you to basically see graphically the cardinality of your metrics directly in Grafana. So you have the dashboard link if you want to have a look. So I'll just do a quick demo of what we've just saw here. So yeah, okay. So okay. So my kind cluster should be up. Okay, so cluster is running. Good. Okay, so it's the other way around. Up. So what I'll start to do is expose my Grafana instance, so I can have a look. Show you. So this is my Grafana instance. So what we need is to create a service account. So we'll add a service account. We'll call it Mimirtool, and we will give it the admin. I'm not sure if it's required, but I think so. And we're going to create a service account token. So yeah, I'm going to copy that. And here, okay. So we're going to save it here. So now that we have an API token, we can analyze our Grafana usage here. So what it did is it's created the metrics in Grafana like we saw in the slides. So as you can see, you have like all the list of metrics that I currently have in this Prometheus instance. And it will also tell you the one, like it would be also available by dashboard. So I don't, I'm running on Kubernetes, and I don't have like flat rules files for flat Prometheus rule files. So I'm going to need to extract them. So I've made a really one command to do that. So I'm just, I now have like all my rules from my Prometheus stack instance. Yeah. So yeah, recording rules, alerting rules, they're all glued together here. And now we're gonna analyze those rules like that, and it created a new file, which is metrics in ruler. Up. And same thing, we have the list of everything that is available in our rules. And now that we have those two, we can expose our Prometheus instance, so we can test this against it. Yeah. So now I'll do Mimirtool and analyze Prometheus, like that. And it will output information, which is also included in the file. So if I have a look at metrics in Prometheus, it's Prometheus metrics, I think. Yeah. So now we have this file, which is basically what we saw. So we have in-use metrics counts, which is basically all the metrics that we use and sorted by cardinality. And we have the same things for, I think it's called other metric counts. So it's pretty easy to have the lists sorted, so you can easily see what you can use, what's used and what's not. So is it? Yeah, so I can show the Prometheus UI here. So as we saw earlier, so the TSDB status is here, and yeah, we can see like the top 10 of our like the 10 highest cardinality metrics of our Prometheus instance are here, but we don't know if they are actually in use or not. So we can, of course, compare that to the file we just created. But I know that this one is not used. So we're gonna pick this one to see how we can like try to understand what labels makes it big. So I'm gonna go back in Grafana. I'm gonna import the Cardinality Explorer dashboard. Yeah, up. Yeah, okay. taking a long time. Okay, here it is. So the dashboards has a pretty nice blocks where it explains everything about how it works at the top and at the bottom. So it's really easy to use once you've read the documentation. But just so you can see, I'm gonna copy paste my metric. And here is it. So here we can see that we have the metric cardinal that we just saw in the Prometheus UI. And here I have the information per label. So as we can see, so it's not loading completely well, but as we can see already, the type is what makes like the largest label from this metric. So of course, we want to check how it looks like, so we can like compare that to the actual values, what's actually inside the metric. So if we look here, we see that the type is the resource. So yeah, obviously it's something that we probably want to keep. So the obvious thing is that we see that this label is huge, is big at least, but we probably need this information. It's probably the purpose of this metrics in the first place. So the second one is LE. So well, of course we are not going to even look at that because we probably infer that we want to keep that. And the last one is operation. So if we look at that, we can see that the operation can be, so I can't see it from here, so we can have list with counts. Maybe we don't need that, like maybe this doesn't do anything for us. So maybe we think about removing this label and how would it affect the metrics series. So here it has a very good feature, this dashboard, is that you can check what would be the cardinality of that metrics without a particular label. So if I do that, so for example, if I try to remove the operation one, it will basically calculate that the cardinality would go from 7,000 to a little bit less than 4,000. So even if, like, as we see, like, it's not obvious that this label, like, it's not the biggest one, but it can have a huge impact on the final metrics cardinality. So if you have like high cardinality metrics, you can use these dashboards to basically like see what you can, if you can remove something to make your Prometheus instance behave, save resource and make it behave faster. So doing that, so need to. So doing that, I had pretty good results. So once I omitted the part where I've like really fixed the Prometheus instance from going out of memory. But after that, using this method, I've reduced my average CPU usage by 120% and average memory usage by up to 140%. So of course, this number would highly depend on where you're coming from. It could be a lot less or a lot more, depending on your setup. But if you never did this kind of exercise, I think you might find do interesting findings here. So last, to finish, I would like to finish on a potential quick win to reduce Prometheus resource usage. So you may have heard this morning during the What's New in the Prometheus land that there was a memory optimization using string labels that is now enabled by default after Prometheus 2.44. Actually, it will also reduce CPU usage. So if you haven't upgraded to this version or a newer one, you should consider, because it's free optimization down the road alongside all the enhancements that's part of the changelog. So that's mostly it. If you want to have a look at the output files of this talk, you can have a look at my github.dc/Prometheus Cardinality. You will have like the output files, and this talk is also based on 2 of my articles that I've written this year, which is the talk is basically a combination of the ideas shared in those 2. So if you have any questions, I'll be happy to answer them.
No questions. Are you sure? All right.
Hi, thank you for the presentation. I was just interested if you were also considering to expand potentially the Mimir tool to look at logs of the queries run in Thanos. You could potentially eliminate then the edge case when people just run a query in the Explore page, so it doesn't show in the dashboard, but they're querying some metrics that you might then delete.
Yeah, so we've discussed that. We didn't have to do it because we generally don't do that a lot, and when we do it, it's generally for incidents. So before dropping anything, we thought about like, even if we don't need these particular metrics, should we drop it? Is it taking a lot of resource, yes or no? If the answer is no, then we should keep it. So that's why you really need to ask that question on high cardinality metrics to see if you're going to keep them or drop them, because obviously you don't know what you're going to need in the future, and especially if you need that, you will have no history if you decided to drop it before. So you need to choose wisely. Okay.
All right, then another applause.